Hi all, we are going to move on in terms of drawing our hyperbola graph, and we are going to look at the equation y equal to 4 over x. In the general form is a over x plus q. For example, the one you have on your worksheet is y equal to 4 over x plus 1. Okay, let's proceed like how we did the drawing of y equal to 4 over x. Bear in mind that once you've completed drawing this sketch, you need to compare the drawing to y equal to 4 over x. And we will use our graph technology to look at the two graphs together. So let's proceed in drawing this graph. If you look at the table of values, we have x equal to minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. We do not need to use all the values. We can use a few of the negative values and some of the positive values. So for example, when x is equal to minus 3, y is equal to 4 over minus 3 plus 1, which gives you an answer of minus 1/3. When x is equal to minus 4, what do you get? Y equal to 4 over minus 4 plus 1, which gives you 0. We can use our calculator in the exams to obtain the y values in the table. So if we start filling in our values, we substitute, we get minus 1/3 in this. For x equal to minus 2, we'll get the answer minus 1 by substitution. When x is equal to minus 1, y is equal to minus 3. Let's take test x equal to 0. We know from our knowledge of number systems that any number divided by 0 would be undefined. So we have undefined when x is equal to 0. Continuing, when x is equal to 1, y is equal to 5. When x is equal to 2, y is equal to 3. When x is equal to 3, y is equal to 2.5. Right, so we have a spread of values in order to draw our sketch. So let's plot these values. Remember your ordered pairs. I just want to take one set of ordered pairs from above. When x is minus 4, you will be plotting the ordered pair minus 4, 0. So there's my dot there on the graph. Likewise, let's proceed. X is equal to minus 3. There's y equal to minus 1/3. You can estimate. When x is equal to minus 2, y is clearly minus 1. When x is equal to minus 1, y is clearly minus 3. Right. We know that at 0, y is undefined. We do not have a value. When x is equal to 1, y is equal to 5. When x is equal to 2, y is equal to 3. When x is equal to 3, y is equal to 2.5. So we can see the shape of our graph from the points that have been plotted there. You notice that our points, if we join them in the first quadrant, they follow a shape like that there. There's our values. We just put that into a different color. There's our values there. There's our values. I just want to shade it in red so that you can see the values clearly. Okay, let's plot the next part of the graph, and we have to join those points, giving us a shape there. Now what's interesting in our graph that we've drawn, that if we take more and more x values, we will see that the graph would come close to this line here, y equals to 1. Y equals to 1. And this would represent our horizontal asymptote in terms of the function. So we are able to see from the sketch that we have a horizontal asymptote, which in our previous graph was the x-axis, but now we see the asymptote, horizontal asymptote, has moved up 1 unit. This is very interesting as we consider our function y equal to 4x plus 1. We can see that this 1 and y equal to 1 does play a role in terms of our horizontal asymptote. You would see this as you draw more sketches as you go along. So, as I said at the beginning, you need to compare the graph of y equal to 4 over x to the graph of y equal to 4 over x plus 1. In other words, what is the transformation of the two graphs? You need to think about this, and we will discuss this. To answer the questions on your worksheet, let's look through them. What would you say is the domain of the graph of M? We could see that the domain is x element of real numbers. Okay, and x is not equal to 0 because 0 plays no role in determining in us determining and getting a y value. For our range, we can see also that y is an element of real numbers, and this time we can see that y is not equal to 1 as determined by our line y equal to 1, the horizontal asymptote. So all y values are part of this function except y equal to 1. Okay. Moving along, we need the equation of the vertical asymptote, which is x equal to 0. Our horizontal asymptote is y equal to 1. What are the equations of the axis of symmetry? I'm going to leave this for you to do some research in finding out how to determine the axis of symmetry. If you notice in terms of a function that if we take the line that passes through the asymptote, this line will represent the axis of symmetry line. So that would be how you would determine the axis of symmetry, but I'm going to leave that for you to do. Our A value was 4, and remember our Q value is 1. In which quadrants does the function lie? We can see clearly it lies in quadrant 1, 2 and also quadrant 3. because it has been raised up. If you look at our graph compared to our previous function, it has now moved up by 1 unit. So our answer here is got 1, 2 and 3. Okay, the question is, how do the two graphs compare? In y equal to 4 over x and y equal to 4 over x plus 1, are there any ideas in comparing the two functions? We notice that the function 4 over x plus 1 is the same as the graph of y equal to 4 over x, but with the plus 1 indicating that the graph is shifted. We see a shift of the graph vertically, a vertical shift of 1 unit. We see a vertical shift of 1 unit upwards. If we look at all our points, we notice that for all our x values, our new y values are moved 1 unit upwards to get the function, and this creates the asymptote line y equal to 1. So we notice also that the q value is the role of the horizontal asymptote. If you have picked up these 2 points, then you have done very well. Please look through your graphs that you have drawn and compare them and make your conclusions in your own words and internalize them. I thank you.